License plate recognition (LPR) camera analyzes the video stream to identify patterns of letters and numbers that correspond to a license plate. Once a plate is detected, the camera performs OCR, optical character recognition, to recognize the characters and convert them into readable textual and numerical data. After recognizing a license plate, the LPR camera can perform three main actions: read and store the license plate locally, or transmit the data to an NVR or VMS for recording and later search. Compare the license plate against an internal database and trigger an action, such as opening a gate via the camera's alarm output relay. Integrate with an access control system using the Wiegand protocol, sending the license plate number for approval or denial of vehicle entry to a specific site. Proper installation of an LPR, license plate recognition camera, is critical for accurate plate detection. Ideally, the camera should face the license plate straight on, aligned with the vehicle's direction of travel. In real-world installations, perfect alignment is not always possible. To avoid image distortion and ensure reliable OCR performance, the horizontal pan angle should not exceed 25 degrees, and the vertical tilt angle should also remain within 15 to 25 degrees, as shown in the illustration. In addition, the license plate should occupy 6 to 50% of the image width, and the vehicle height should be at least 10% of the frame height, ensuring sufficient detail for accurate recognition. Within the camera scene, you can define a detection area where the LPR camera actively searches for textual characters, such as license plates. In addition, a blocking area can be defined to exclude zones where text should be ignored. As shown in the example, a truck may have additional text above the license plate, such as a vehicle or fleet number. By placing a blocking area over this region, the camera avoids reading irrelevant characters and focuses only on the license plate. If the detection area and blocking area overlap, the blocking area has priority, meaning no text will be read in that region. An LPR camera supports one detection area and one blocking area. LPR cameras include an OCR comparison mechanism that allows for misreading up to 2 characters. This is useful when a license plate is partially obscured by dirt, snow, or motion blur. If 1 or 2 digits are unreadable, the camera can still match the plate against its database and treat it as a valid, allowed entry, for example, triggering a gate to open. This behavior is configurable, allowing you to define how many characters, up to 2, may be misread while still accepting the plate as a match. In addition, the camera supports similar character mapping. Some letters and numbers can look alike during fast motion. For example, Z to 2, B to 8, O to 0, I to 1. By defining these similarities, the camera can automatically convert between them during comparison, increasing recognition accuracy when matching plates against the database. LPR deduplication is a mechanism designed to control how often the same license plate is reported while it remains visible to the camera. When deduplication is disabled, the camera detects and processes the same license plate continuously for as long as it stays in the scene. When deduplication is enabled, the camera reports the same license plate only once within a defined time interval, for example, every 3 seconds. As long as the plate remains visible, additional detections are suppressed until the deduplication period expires. If the plate disappears from view and is detected again later, it is treated as a new event. This feature is especially useful in real-world scenarios, such as access control alerts. If a vehicle stops at a gate and does not proceed, repeated reads can trigger alerts to an operator after several consecutive detections. Gate control logic. For whitelisted vehicles, repeated detections can be used to keep the gate open while the car is still waiting to enter, preventing the gate from closing prematurely. Deduplication helps reduce unnecessary event flooding, improves system logic, and ensures cleaner integration with access control and alarm systems, while still allowing flexibility through configurable time intervals. An LPR camera can be deployed in several common scenarios. Street monitoring, the camera monitors traffic and registers all passing vehicles. It can also generate alerts when a license plate matches a blacklist or watch list. Standalone operation, the camera is connected directly to a gate and opens it based on an internal allow list of license plates, without relying on an NVR. NVR-based system, multiple LPR cameras are connected to an NVR, which stores the vehicle database and controls gate operations. In this setup, the cameras perform only license plate recognition, while all decisions and gate control are handled by the NVR or VMS. Inside the camera, there is an option to enable double verification using the Wiegand protocol. In this setup, an external card reader sends an RFID tag number to the LPR camera via Wiegand input. In the LPR interface, this tag is treated as an access card, while the camera simultaneously reads the vehicle's license plate number. The camera performs a combined check of the detected license plate number and the received access card number. Only when both credentials are valid does the camera trigger its alarm output to open the gate. This means the Wiegand interface is used not only as an output from the camera, but also as an input into the camera, enabling a higher level of access control security. Let's look at how the LPR camera integrates with an external access control system using the Wiegand protocol. Once the LPR camera reads a license plate, it can transmit data to the access controller in one of two ways: as an access card number, which corresponds to an internal identifier stored in the camera's database, or as the license plate number encoded using SHA-1 sent over the Wiegand interface. The access control system receives this data and performs its own verification. If the license plate or access card number is approved, the controller then sends a command to open the gate. Today, the cameras support Wiegand 26 and Wiegand 34, which transmit numeric data only. For this reason, the license plate itself cannot be sent directly as text. Instead, it is converted into a numeric SHA-1 hash, allowing it to be transferred over Wiegand and compared on the access control side. In the upcoming 64-bit Wiegand version, the camera will be able to transmit alphanumeric characters, allowing license plate numbers to be sent directly without relying on hash conversion. To clarify the two integration methods, when SHA-1 is used, the LPR camera does not store any numbers in its internal database. Each detected license plate is automatically converted into numeric data using the AbuTech conversion and sent directly to the access control system via Wiegand 26-bit. When integration is done via an access card number, the LPR camera does store a license plate database in its internal memory. Each license plate is associated with a specific numeric access card number, and this number is transmitted to the access controller using Wiegand 26-bit. In short, SHA-1 mode converts and sends, while access card mode stores, maps, and sends. This slide summarizes and clarifies the two LPR integration methods. In access card number mode, the LPR camera stores the license plate database internally and associates each plate with a numeric access card number. When a vehicle is detected, the camera sends the corresponding access card number to the access controller via Wiegand 26. In SHA-1 mode, the LPR camera does not store any license plate numbers. The camera automatically converts the detected license plate into numeric data internally and sends it to the access controller over Wiegand. The AbuTech calculator is provided only as a reference tool to help users understand how this conversion works. It is not required for system operation, since the conversion is fully handled by the camera itself. The LPR camera includes a direction-based recognition feature that allows it to detect vehicles moving in a specific direction, either approaching or leaving the camera. This detection is based on the vehicle's movement within the image, typically along the y-axis. As a vehicle approaches the camera, the license plate appears larger in the frame. As it moves away, the plate becomes smaller. Using this behavior, the camera determines the direction of travel. In the recognition mode settings, you can choose whether the camera should detect only approaching vehicles, only leaving vehicles, or both, depending on the installation scenario. This function works best on straight roads. If a vehicle turns while moving toward or away from the camera, direction detection may be less accurate. The LPR camera includes a configurable alarm output holding time, which defines how long the relay remains active after a whitelisted vehicle is detected. This relay output is typically connected to a gate or barrier controller. Once a valid license plate is recognized, the camera triggers the alarm output and keeps it active for the defined duration, ranging from a few seconds up to longer periods, or even continuously if required. This is especially useful in scenarios where the gate needs to stay open long enough for the vehicle to pass safely, preventing the gate from closing too early. By adjusting the alarm holding time, you can fine-tune gate behavior to match vehicle speed, traffic flow, and site-specific safety requirements. Let's take a look at how the LPR camera works in practice. For demonstration purposes, the camera is installed on a window, not an ideal installation, but it is sufficient to showcase the device's full functionality. We start by opening the camera's web interface for configuration. On the right side of the live view, you'll find control icons that allow you to zoom in, zoom out, and adjust the camera angle to optimize the detection area. Next, we go to Configuration and begin setting up the camera. To configure license plate detection, navigate to Analytics, License Plate Detection. The first step in this interface is to enable license plate detection by checking the Enable checkbox. Next, we need to define the detection area. In our case, the camera is pre-configured to use the entire frame, so we'll first clear it. Then we click Draw Area and mark the specific zone where vehicles should be detected, typically near the gate or barrier. We can also define a blocked area, as explained earlier, to prevent the camera from reading license plates in unwanted regions. Since the camera is operating in standalone mode, we enable saving both the original image, the full frame, and the object image, the cropped license plate. Both images are stored on the camera's SD card, so we go to the stored settings to confirm that an SD card is installed. To start clean, we format the card and verify that it's ready for use. Returning to license plate detection, we select the operating region for the camera. In this case, we choose Israel from the list. Finally, we enable plate absence capture. This ensures that an event is recorded even when no license plate is detected, either because the vehicle is approaching at an angle that makes the plate unreadable, or because the plate is physically absent or obscured by dirt or damage. This provides an additional trigger for storing such events for later inspection, even when license plate recognition itself is not possible. As covered earlier, we can also configure the object size, meaning the license plate size. Here, we can define the minimum and maximum width and height of the plate. This fine-tuning is typically needed only in special calibration cases. In the Schedule tab, we define when license plate detection should be active. We can clear the schedule, manually add specific time periods during the week, and also configure schedules for future holidays. In the Linkage tab, we can enable video recording to the SD card for license plate events. In Storage, Record, we set the video quality to be saved on the SD card, choosing either the mainstream or the substream. We can also enable pre-recording, so the video includes a few seconds before the event occurs. Finally, if we go to Data Record and click Search, we will see no license plate events yet. This is expected, since the SD card was just formatted and no vehicles have been detected so far. Now let's see how the camera behaves when it actually detects a vehicle. When we click the small icon at the bottom of the interface, the detected license plates are displayed on the right panel. As a vehicle enters the detection zone, a snapshot of its license plate appears in this panel. If another vehicle enters but approaches at an angle that prevents proper plate detection, the camera generates an unrecognized event, which can still be reviewed later. If we go to Data Record and click Search, we can see both events, one with a recognized license plate and another without a detected plate. By clicking on a license plate snapshot, we can view the full frame image of the event, exactly as configured earlier. This image is stored on the camera's SD card. Finally, in the search area, we can review all recorded videos. By selecting today's recordings, we can see two video clips, one related to the unrecognized license plate event and one related to the recognized license plate event. Now we configure the camera to detect only vehicles that are leaving, meaning vehicles moving upward on the y-axis. In light view, you can clearly see that even when a vehicle enters a detection zone with a clearly visible license plate, it is not detected. The license plate is detected only when the vehicle starts moving away from the camera, going up on the y-axis. This demonstrates how direction-based detection works and how the camera triggers recognition only for the selected direction of travel. Now, let's look at the deduplication function. We switch recognition back to work in both directions and enable the deduplication option, setting it to generate a detection event every 4 seconds. In live view, you can see that once a vehicle enters the detection area, the camera generates a new detection event every 4 seconds, even though it is the same license plate. This behavior is intentional. If the camera is connected to an access control system, it can indicate that a vehicle is standing in the same area for an extended period, rather than just passing through. When we go to Data Record, we can clearly see multiple detection events logged for the same vehicle, all corresponding to this deduplication interval. Now let's talk about missing license plate detection and database handling. As shown earlier, we can enable Capture Plate Absence Vehicle. When this option is checked, the camera registers an unrecognized event if a vehicle approaches at a sharp angle that makes the license plate unreadable. When the vehicle is detected at a proper angle, the license plate is captured normally. Next, let's see how to add a vehicle to the camera's database. Go to Vehicle Database and click Add. Here, we enter the license plate number, select the list type, such as Allow List or Block List, Define the validity period and optionally add owner details like name, phone number, or access card. The access card field is relevant only when working with an external access control system. Once saved, the license plate appears in the camera's database. After that, we move to the Comparison and Linkage tab, where we define the camera's reaction to detected plates. For example, under the Allow list, we can enable Alarm Out, which instructs the camera to open the gate when a whitelisted plate is detected. If an external access control system is used, we can also enable Wiegand Output and choose whether to send an access card number or the license plate data. In this setup, the camera's alarm output is connected to a tester device. When a whitelisted vehicle is detected, we see the alarm output icon appear, and the tester beeps, confirming that the relay has been activated, simulating a gate opening. As covered earlier, we can also configure how long the alarm output remains active to ensure the gate stays open long enough for the vehicle to pass. So far, we've covered how the camera reacts to the allow list by triggering the alarm output. The same configuration can be applied to other list types from the same Settings tab. Now let's move back to the vehicle database. At this stage, we've added only one license plate manually. By clicking Edit, we can view its details or delete it. Since the next step is to import a larger database. To import multiple license plates, we first download the CSV template provided by the camera. This template defines the exact structure the camera expects. To avoid formatting issues, we open the CSV file first in a text editor such as Notepad++. Here, we can see that the date format is strictly defined as YYYY-MM-DD. 4 digits for the year, 2 for the month, and 2 for the day. If we open the same file directly in Excel, Excel automatically converts the date format based on the Windows regional settings. This changes the structure, reordering the date, which breaks compatibility with the camera. To fix this, we copy the original date text, change the relevant Excel columns to text format, and then paste the date back. Now we can set the date exactly in the format the camera expects. We repeat the same process for the end date, for example, setting a validity period of several years. Once the file is filled with license plate numbers, owner details, and list types such as allow list, block list, or temporary list represented by numeric values, we save it again as a CSV file. The database is now ready to be imported into the LPR camera. Now let's talk about missing characters and similar digits. As covered earlier, the camera allows you to define how many characters, up to 2 digits, can be misread. You can also configure similar characters, such as O and 0, 2 and Z, 8 and B, and others. This way, if part of the license plate is obscured by dirt or snow, or if similar characters are misinterpreted due to motion, the camera can still match the plate correctly against the database and allow access when appropriate. Next, let's look at the day and night operation of the camera. In the Image Display settings, we can configure separate profiles for day, night, and common modes. Through Profile Management, each mode can be fine-tuned, and the camera can automatically switch between day and night operation. In night mode, the camera automatically reduces image brightness to prevent overexposure caused by infrared reflection from the license plate, ensuring the plate remains readable. At the same time, the shutter speed is automatically adjusted, typically to 1/500th of a second, to capture a sharp image and avoid motion blur from moving vehicles. We can configure a schedule to switch between day and night profiles at specific times, ensuring the camera operates in the correct mode during defined hours. Alternatively, we can switch to the Common mode, where the camera automatically changes between day and night based on ambient lighting conditions. In Common mode, the switching is automatic, and we can adjust the sensitivity that triggers the transition. A useful tip here is to configure a switching delay. This prevents the camera from immediately switching to day mode when it receives strong light from vehicle headlights at night. Instead, the camera waits a few seconds before changing modes, helping it remain in night mode under temporary light spikes. Additionally, we can set the shutter speed to a constant 1/500th of a second, and enable Smart IR, which automatically adjusts infrared intensity based on reflections from the vehicle. This helps prevent overexposure and ensures clear license plate capture in varying lighting conditions. Up to this point, we've discussed the camera operating in standalone mode. Now let's look at a scenario where the LPR camera is connected to an NVR and reports all detection events directly to it. When we open Analytics/LPR in the NVR interface, we can see that the camera is already connected. Most of the settings shown here mirror what was configured on the camera's local web interface. One key difference is the detection area. When the camera is connected to an NVR, the detection area must be defined from the NVR interface. Here, we draw a rectangular detection area, and if needed, we can also define a blocked area, with some more flexibility. If we then return to the camera's web interface, we can see that both the detection area and the blocking area now reflect the configuration made on the NVR. In the Recognition section, the NVR receives and registers all LPR events reported by the camera, making them searchable later. In addition, the NVR allows us to apply system-level actions to these events. For example, we can react differently to allow list or block list plates, or send push notifications when an unrecognized license plate is detected, such as when a vehicle not listed in the database appears at the entrance, alerting the property owner. Go to the Analytics section of the NVR and select Vehicle. Choose the LPR camera we installed earlier, then select the event types. plate recognition successful and plate recognition unrecognized plate. This ensures we retrieve all LPR events reported by the camera to the NVR. After clicking Search, the events appear in the results list. We can preview or play them back by clicking on a license plate snapshot and use the three-dot menu to view detailed information about the plate. Next, we can define reactions at the NVR level. In the LPR settings of the NVR, we can configure actions for successful recognition, meaning the detected plate matches an entry in the NVR's database, and set these actions to run on a 24/7 schedule. The same applies to unrecognized plate events. At this point, it's important to note that the NVR database is currently empty. To enable allow list and block list logic, we need to create and maintain the vehicle database inside the NVR. From this stage onward, the NVR becomes the central system holding the database rather than the LPR camera itself. Let's create vehicle groups in the NVR database. First, we create two groups, an approved list and a block list, similar to how face groups were created earlier. In the approved list, we add a license plate by entering the number, assigning it to the group, and optionally adding owner details. The same process is repeated for the block list. If needed, multiple vehicles can also be added using bulk entry with a CSV file. Once both groups are created, we return to the LPR recognition settings in the NVR and link reactions to each group. For successful recognition of an approved list vehicle, we can trigger an alarm output to open the gate. For the block list, we define a different reaction, such as displaying a warning message and sending a push notification to alert the owner. This allows the NVR to react differently based on whether a detected vehicle is approved or blocked. Before verifying that everything works as configured, we first return to the local interface of the LPR camera and clear its internal database. From this point on, the LPR camera should not store any license plate data. The NVR becomes the only system responsible for decision-making. Now, when a vehicle from the approved list appears, the NVR displays a welcome notification and the gate opens automatically. For testing, we then move the same vehicle from the approved list to the blocked list in the NVR database. When the vehicle appears again, it is now treated as blocked. The guard sees a warning message and a push notification is sent to the owner's phone via application. In the push notification settings, we can control whether notifications are enabled and which LPR events should trigger them. Once enabled, every time this blocked vehicle appears in front of the camera, a plate recognition alarm notification is sent to the mobile app. From the app, we can also play back the event and review exactly what happened.
When the camera operates in standalone mode without being connected to an NVR, the user can still control it and view the live stream remotely. To do this, the P2P option must be enabled on the camera, and then the camera's QR code is scanned from within the Cam2 application, using the QR code shown in the Basic Information tab of the camera. Once the camera appears in the Cam2 application device list, the user can search for events stored on the camera's SD card or manually trigger the alarm output to open a gate if needed.